Hello students, let us start with the module 4, that is software testing. In this module we are going to cover the topics like development testing, test driven development, release testing and user testing. Now we'll see what is the meaning of program testing, how it is done and what are the advantages of having a testing everything in this particular chapter. Okay, testing is intended to show that a program does what it is intended to do and to discover program defects before it is put into use. Right, this is the basic thing. Whenever some program is developed, it has to be checked whether we have any problem in the application that is being developed. If it is having any errors, then again the user will be coming up with request. Okay, there are so many errors in this, you have to modify it. Right, so what we do is before giving a application to the customer, we will be testing it, right? So that is the general testing process. When you test software, you execute a program using artificial data. But the thing here is, when you are testing a program what is developed by the developer, you are testing with artificial data. That is, you are assuming this might be the input that will be given by the customer, and you will try to find out is there any bug present in the application or the program that is being developed. You check the results of the test run for errors, anomalies, or information of the program's non-functional attributes. When we test the application, we are checking whether there is any error present in the application or whether we have any anomalies or information of the program's non-functional attributes. Non-functional attributes are like whether application is resistant to any kind of attacks, right? That is the securities. Then we'll be looking for the things like usability. Everything is being tested over here. And when we test the program, we can reveal whether the presence of errors. We can check whether errors are present, but we cannot tell that errors are absent in the application that is being built. Right, that is the thing over here. Testing is part of more general verification and validation process, which includes static validation techniques as well. Okay, we'll be seeing it in the next slides. What is the goal of testing? There are two specific goals. The first goal is to demonstrate to the developer and the customer that the software meets its requirement. This is the first goal of having a testing. For custom software, there are two kind of softwares, right? One is custom software and the one is generic software. For custom software, why we go for testing is when we test the things, this means that there should be at least one test for every requirement in the requirements document. Whatever the requirement document we have considered over here, for each and every requirement there should be a separate test. If it is a generic software products, it means that there should be tests for all of the system features plus combinations of these features that will be incorporated in the product release. So these are the two kind of softwares, and for each and everything there will be having a testing phase. Then we have a second goal to discover situations in which the behavior of the software is incorrect, undesirable, or does not conform to its specification. We have two goals. One thing is we will be showing to the customer that there is no problem in the software that we have built, and the second thing is to discover situations in which the behavior of the software is incorrect, undesirable, or does not conform to its specification. So defect testing is concerned with rooting out undesirable system behavior such as system crashes, unwanted interactions with other system, incorrect computations, and data corruption. So this is the second goal of having a testing. Uh, we have two kind of testing. One is validation testing and second one is defect testing. The first goal leads to the validation testing, wherein you expect the system to perform correctly using a given set of test cases that reflect the system's expected use. As a customer has requested, if you are developing the application and you are giving to the customer, that means validation testing is done properly. And the second goal of having a testing is there should not be any bug present in the application that you have built, right? That is, the test cases are designed to expose defects. The test cases in defect testing can be deliberately obscure and need not reflect how the system is normally used. So this is the goal of testing process. Validation testing, it is used for demonstrating to the developer and the system customer that the software meets its requirements, what is given by the customer. And a successful test shows that the system operates as intended. If you develop a testing and you give a application to the customer, if everything is working fine, that means you have done a correct testing, and if it is accepted by the customer, that means validation testing has been done properly. Second one is about defect testing. Why we go for this defect testing is to discover faults or defects in the software where its behavior is incorrect or not in conformance with the specification. If the application is not according to the specification, that means you have some problem in the application that has to be altered, right? A successful test is a test that makes the system perform incorrectly and so exposes a defect in the system. If there are any problem in the system that you have built, and if you apply a testing strategy, and if you are able to find out those errors, that means you have done testing properly, or else there is a problem with the testing process. Next one is regarding a input output model of program testing. How the testing is carried out, we'll be having input test data with us, and then we'll have the system which is developed by us, and then we will be having what will be the expected output. When we give a correct input, what's going to happen is we will be getting the expected correct output because everything is working fine. If we give a wrong input to a program, that is erroneous input, whatever we call it as, when we give a erroneous input to a program, then what happens is we'll be getting the output which reveal the presence of defects. Then we say that testing whatever is carried out is correct. Now let us see the difference between verification and validation. What is verification and what is validation? Verification is a process wherein we are checking, are we building the product right? How we are building the product? By looking at the specification. That is, the software should conform to its specification. When we have developer application, by considering the specification, then we check whether everything is according to the specification, and if it is so, then we say that everything is working fine. Then what is validation? Validation is, are we building the right product? Right product in the sense whatever is asked by the customer. If you are building that product, that means you have developed a correct product. That is a validation testing. The software should do what the user really requires. Whatever is required by the customer, if you build that thing, that means you have correctly developed the application and your validation testing is correct. Verification and validation confidence. Aim of V&V is to establish confidence that the system is fit for purpose. Why actually we go for verification and validation as we want to show to the customers or the end users that this is working fine. There's no problem in using this particular application, and whatever you had requested, it's according to your request, right? So that is the main aim of V&V, and this depends on system's purpose. Whatever the verification validation will be having, it depends on system's purpose, for what reason it is being used, what is the kind of user expectation, and the way it is being marketed. Now if we consider software purpose, the level of confidence depends on how critical the software is to an organization. If our application is so critical, then we go for much and more verification and validation testing over there. If we consider a application wherein users expectation is low, then even if you are going with less verification validation process and you give it to the customer, already customer is having low expectation on your software, then you can have less verification validation technique applied on that, and you can give it to the user will be using it. Then the third kind of thing is a marketing environment. Let us assume that you want to build some product and you want to be the first one to release that product into the market. Then you go for less V&V, that is verification validation, because you want to market your product in a such a way that you should be the first one to release that product into the market. Then V&V, whatever verification validation technique that is being applied on a software, it varies, right? Then we will see about inspection and testing. What do you mean by inspection and what do you mean by software testing? Software inspection, it is concerned with analysis of the static system representation to discover the problems which are static in nature. Okay, there are so many things that are static in nature, which can be uh, checked properly if you go with an inspection process. If you go with the testing process, then there is something that it will be missed. Okay, we'll be saying that in the next slide. Okay, and if you're going with software inspections, you have a lot of tools through which you can go for inspection process. Then software testing is concerned with exercising and observing product behavior. That is, you'll be writing a code, and then that code will be given a input, and you'll be looking whether we get a correct output as we have predicted. Right, so that we are checking the dynamic nature of the application that we have built. The system is executed with test data, and its operational behavior is observed over here. This is the inspection process. Inspection can be applied to many phases of the development of an application. Inspection can be applied during the requirement specification phase, or it can be applied to a system prototype that is being built according to the requirement specification. And inspection is being carried out for the software architecture, UML design models, and inspection also can be applied for database schemas that we are going to produce. And inspection can be also applied for the overall program that we are going to build. Right, so inspection has its application in the multiple phases. When we go with the testing can be applied only to the system prototype. Right, prototype is a model that is being replicated as the final version of the application that we are going to build. For that we can have a testing, and for overall program we can go for testing. Right, this is the importance of inspection as well as testing. Testing cannot be applied for the requirement specification, software architecture, UML design models. For all these things, we cannot apply a testing. Testing can be only applied for the overall program that we have built, or else it can be applied for the system prototype. Software inspections. This involve people examining the source representation with the aim of discovering anomalies and defects. What is the main goal of inspection processes? Here, team is involved in discovering whether there are anomalies present in the application that is being built, or whether we have defects in the application. Inspections not require execution of a system, so may be used before implementation. Why we can apply our inspection processes? Because it is not mandatory that overall program should be there, then we can apply a inspection process. No, inspection can be applied at any duration during the application development process. They may be applied to any representation of the system during the requirement phase, or during the design phase, configuration of the data, test data, everywhere this inspection process can be applied. They have been shown to be an effective technique for discovering program errors. If there is any error, then we can go for this inspection process for finding out the errors. Now let us see the advantages of having an inspection. The first advantage is, during testing what happens is, errors can mask or hide other errors. Because when we give an input, we might be getting an output, and then we come to a conclusion that this error is because of so and so problem. Okay, but there might be multiple reasons for getting a wrong result, but we will concentrate only on a part of a error that is being shown over there. Right, so because inspection is a static process, you don't have to be concerned with interaction between the errors. So this is one advantage of having an inspection process. Then second thing is, if you are having an incomplete versions of a system, that can be inspected without additional cost. If a program is incomplete, then you need to develop specialized test harness to test the parts that are available. If your program is incomplete, then you cannot go for testing. If you want to go for testing, then you need to make use of some specialized test harness processes. The third one is, as well as searching for program defects, an inspection can also consider broader quality attributes of a program, such as compliance with standards, portability, and maintainability. Everything can be checked by considering the inspection process. If you have inspection process, then you can check whether whatever the application we have built, it is according to the standards or not, whether it can be portable, and whether easily this can be maintainable or not. Everything can be checked by this inspection process. Inspection and testing. Right, inspection and testing are complementary and not opposing verification techniques. They are not opposite of each other, but they go hand in hand, right? Whenever we are developing an application, for some part we will be applying an inspection process and some part we will be applying a testing process. Both should be used during the V&V process. Then inspection can check conformance with the specification but not conformance with the customer's real requirement. The problem with inspection is how we are checking the things is we'll be looking at the specification document, and according to that document only we will be checking whether everything is working fine. So this is one of the disadvantage of having inspection. Inspection cannot check non-functional characteristics such as performance, usability, all these things we cannot check because this can be tested when we have overall application. Then we can go for testing the performance by giving the inputs, and we can also go for checking the usability when we have a full application. We cannot have a part of application and go for checking for performance, usability, all these things. This is a model of software testing process. Here what we have is, first thing is we have to design the test cases. That is how we will be testing the things when our application is being developed. Right, before building the things, you go for designing the test cases. So the output of this test design test cases is a test cases. You can see it in a rectangle at the top. Then we go for preparing the test data. When test cases are done, then you go for preparing the test data. Then when this process is done, then you'll be having a test data with us. Then we go for running the program with test data. We'll write a program, then we give this test data as an input, then we'll be getting a test results. This test results will be compared with the test results. This results will be compared with the whatever the program we have written. We'll be giving this test data as an input, right? Then we will be getting this output from the program. This program output will be will be compared with test results. If everything is working fine, then we generate a report, the program is working fine. If we get a deviation from what is expected, then we say that the program is having some kind of errors that has to be debugged. Stages of testing. We have 3 testing stages. First one is during the development, we'll go for testing, that is known as development testing. Then release testing, before giving it to the customer, we go for testing. Then we have unit test, user testing. Okay, we'll see that each thing. Development testing is a testing where the system is tested during development to discover bugs and defects. During the development process, we will be checking the things, and that testing is known as development testing. Then we have release testing. Release testing is a testing where a separate testing team is ready with their test data, and they go for testing a complete version of the system before it is released to the users. Then the third kind of testing is a user testing, where users or potential users of a system test the data in their own environment. Till now, whatever the testing is done, it was carried out in the development organization only, wherein we go for development testing and the release testing, but the user testing will be done at the user location or the user environment. Development testing. In development testing, again we have a unit testing, component testing, and system testing. In unit testing, what we do is where individual program units or object classes are tested. Right here, when we go for testing individual units, if you're going with the object-oriented development, then you go for creating the classes, object classes. Here we check for whether each object class is working fine. Unit testing should focus on testing the functionality of objects or methods. Then is a component testing. In component testing, where several individual units are integrated to create a composite components, here component testing should focus on testing the component interfaces. Right, in a single component we might be having individual units, and they might be having an interconnection with each other. They might be transferring some message, right? So that is being checked whether the information that is passing from one unit to another is working fine or not. At the last, we have a system testing, wherein we club all the components, then we get a integrated system. Now this system is tested as a whole, right? System testing should focus on testing component interactions. There might be multiple components in a overall unit that we get at the end. Here we are testing for system as a whole, whether everything is working fine or not. Regarding the unit testing is a process of testing individual components in isolation. It is a defect testing process, and units might be your individual functions or methods within an object, or it might be object classes with several attributes and methods, or it might be composite components with defined interfaces used to access their functionality. Object class testing, how this is being tested, how the object classes are being tested. Complete test coverage of a class involves testing all operations associated with the object might be having multiple operations to be done, that will be tested separately. Then setting and integrating all object attributes, there might be multiple object attributes, we will be giving the values for that and we are testing the things. And exercising the object in all possible states, there might be multiple states wherein our object will be going through its transition. So uh, we'll be setting all the states and we go for testing the things. And inheritance makes it more difficult to design object class testing, as the information to be tested is not localized. Because when we make use of inheritance, what's going to happen is there might be some methods or there might be some objects which are present in some other class and it is being inherited in the class which we are testing. Since it is not localized, it will be little difficult to go for testing process. This is a weather station object interface wherein we have three parts, right? At the top we have name of a class, that is weather station. Then we have object, that is identifier. Then we have methods, right? Report weather method, report status method, power save, with parameters that are present over here. How the weather station is being tested is need to define test cases for report weather, calibrate it, test it, startup, shutdown. So these are the various methods, right? Whatever the methods we have over here, all the functions, every function will be called and it is being checked whether everything is working fine. Using a state model, identify sequence of states transitions to be tested and the event sequences to cause this transition. For example, if the weather station is in shutdown state, then go for running, then go for shutdown. You have to check whether shutdown and running is working fine. Then if you want to configure your weather station, go for running, then test the thing, then transmit the data and go for running. So we are making our object to go through a particular state and we are checking everything is correct or not. Then we have automated testing, right? Everything cannot be a manual. When we go for modifying something and then we go for manual testing, it takes time. Instead of this, what is going to happen is we can go for automated testing. Whenever possible, unit testing should be automated so that tests are run and checked without manual intervention. When we change something, then automatically this program has to execute and it has to be tested automatically. In automated test, unit testing, you make use of the test automation framework known as JUnit to write and run your program test. You're going to write your program test and then you're going to run this program test so that you are checking everything is working fine. Unit testing frameworks provide generic test classes that you extend to create specific test cases, right? There will be some generic cases, test cases, then you you extend it, you modify it according to your need, then unit testing will be occurring again and again automatically. They can then run all of the tests that you have implemented and report often through some graphical user interface on the success of or otherwise of the test, right? Whatever the application you have developed, it will be checking itself whether everything is fine. If there is any problem, through this graphical user interface we can report either the success or failure of the test. What are the components involved in this automated testing? There are three components. One is a setup part, another one is call part, the third one is a session part. What is the work of setup part, right? A setup part where you initialize the system with a test case, namely the inputs and expected outputs. What will be present in a setup part? Setup part involves the set of inputs and set of expected outputs. Then we have a call part. What is the work of call part is where you call the object or method to be tested. If you have written your own method or the object and you want to test that, then you call this method, right? Then uh, a testing will be done over here. And we have last part known as assertion part, where you compare the result of the call with the expected result. If the assertion evaluates to true, the test has been successfully carried out. If false, that means it has failed. Then we have unit test effectiveness. When we say that unit testing is correctly carried out, the test cases should show that when used as expected, the component that you are testing does what it is supposed to do. If you have a unit with you and if you have tested it and you are getting the result as you are expected, that means you have correctly done the unit testing. If there are defects in the component, this should be revealed by the test cases. You know that there are some problems in the application that you have built and you have tested it, but your testing has not revealed any errors. That means you are not done testing properly. And this leads to two types of unit test cases. The first of this should reflect normal operations of the program and should show that the component works as expected. When we go for testing, our goal is two things. One is we have to show to the user everything is working fine, and the second goal is if there are any problems, we have to identify that. Right. So these are the two goals of the testing process. Then regarding the testing strategies, here we have partition testing where you identify groups of inputs that have common characteristics and should be processed in the same way. Right? When we can test the things according to the partitions, what we do is we will partition the inputs and whatever the output we get, again that will be coming under the partitions only. You should choose tests from within each of these groups, and we'll see this in the next slide, right? How the testing is done, how we are going to choose the inputs and all. There are two things, right? There are two ways of having a testing. One is partition testing, wherein you identify the groups of inputs, whatever has to be given to the program, and then you expect a particular output. And other way of having a testing is guideline based testing. You have a guideline set with you and you give an input in such a manner that you go through this guideline and you expect whatever is required for you. Let us study about partition testing. Input data and output results often fall into different classes where all the members of a class are related, and you go for having an equivalence partition or the domain partitioning where the program behaves in an equivalent way for each class member. Test cases should be chosen from each partition. Consider this example wherein we go for equivalence partitioning. Let us assume that if we give a number which is real number, then for all the real numbers your program will be working in a same manner, right? If you give a negative number, your program might be working in a different way. If you give a number which is a 0, that program might be working in different way. So when we are choosing the equivalence partitioning, what we do is we choose a set of inputs, right? Each oval shows it is a set of inputs, and at the right side we can see the again partitioning which is in a oval, which shows when we give a particular input we can expect the same kind of output from the application that is being result of this application will be same. Let us consider an example. Let us consider example wherein we have written a program in a such a way that that program accepts 4 to 10 numbers, right? If I am giving less than 4 numbers, if I give 1, 2, 3, only 3 numbers, our program is not going to accept because I have given only 3 inputs. First input is 1, second input is 2, third input is 3. If I give 4 inputs, like 1 is my first input, second input is 2, then 3, then 4. That means 4 inputs I have given, then only our program will be processing the information that it has received. And it is in the range of 4 to 10. If I am giving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, it's okay. If I am giving 11 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the next number is 11. If I am giving more than 10 inputs, then our program should not work. So our permissible range is between 4 and 10. That is regarding the number of input values. Then we have second diagram which tells us our program accepts a number if it is 5-digit number only, right? When we say that number is 5-digit, if it is having 5 digits, 5-digit number starts from the first 5-digit number is your 10,000, right? If I'm giving 9,999, then our program should not process that information. If I'm giving a number which is 10,000 and greater than that, but less than 99,999, then only our program should work. So this is the way in which we have gone for equivalence partitioning. If I'm giving 1 lakh, right, since 1 lakh is having 6 digits, our program should not process. Then regarding the testing guidelines, test software with sequences. When we have a sequence as a input, then how we are going for testing is, this is our testing guideline. Test software with sequences which have only a single value, right? You give a value which is a single value, but your program is expecting a sequence of inputs. We need to give 4, 5 inputs and all, but if you're giving single input, how the program is going to respond, that we have to check. Then use sequence of different sizes and different tests. First you give a 2-digit number, then go for 3-digit number, 4-digit number, 5-digit number, and you test the things. Then you will come to know for what number or for how your program is behaving for the particular sequence of numbers. Then derive tests so that the first, middle and last elements of the sequence are accessed. If you are searching for a number, now you apply a testing in such a way that you go for accessing a number which is in the first location, middle location and at the last location. Then the other kind of guideline that is given is test with sequence of 0 length, right? If you don't give any input, just enter the things, how your program is responding to your input, just go for that. So this is regarding the testing guidelines when we have sequence to be given as an input. Now we have a general testing guideline. General testing guideline is choose inputs that force the system to generate all error messages, right? We have to give a wrong input or the inputs in a such a way that if you have written some exceptions, right, we have written some exceptions and all, then we have to generate all the error messages over there. Then the second guideline is design inputs that cause input buffers to overflow. Okay, we have to give a number in such a way that input buffer should overflow. And the third one is repeat the system inputs or series of input numerous times. Same, right? Repeat the same input or series of input numerous times. That is, you give the same number as an input and check whether you'll be getting the same output for the number that you are given as an input. Okay, you have to repeat multiple times. Then force invalid outputs to be generated. Okay, you have to choose an input value in a such a way that you have to get a invalid output also. Then force computation results to be too large or too small. You have to check when we give a number in a such a way that if I'm getting a small value as an output, how my program is going to respond. Or if you give a different number and if you get a too much or too large valued output, how your program is going to respond to that you have to check. So these are the general testing guidelines when we go for having a testing procedure. Thank you.